This is issue number 62 of the Kaiju Engine, where we're going to be setting up textures and the texture cache. So we'll be doing that instead of renderer. We'll do texture.go, and then we can also make a texture cache.go. Okay. So this is just the abstract texture. It's not related to OpenGL or Vulkan at all. We're going to be creating the textures in those two rendering pipelines and their own rendering code. So here's just the basic identity. So we're going to start off with a texture color format. It's one of the things we're going to have to deal with. And then we can create those texture color formats. We're going to do texture color format RGBA unorm is equal to, well, we can copy this and put it here. iota texture color format RGB unorm. Then we're going to do sRGB and then do that one as sRGB, and then texture color format luminance. Those will be our formats, and then we're going to have, I'm going to create it up here actually, type texture filter. And these are going to be, this is going to be equal to int, so it's going to be basically identical. We'll make a const for that, texture filter linear, and then texture filter nearest. Then we're going to have another type, texture mem type, and this one's going to be texture mem type unsigned by 2. We only have this one for now, and then we can add more to it later. And then type texture file format. We're going to support PNG. Actually, let's start off with texture file format ASTC. Guess this needs to go up here. And then texture file format raw. Those are going to be our 3 for now. We may implement ASTC later, but I just kind of want it there for when we get around to that. Then we're going to have a cube map side. I guess this would be cube map sides. It's just some arbitrary configuration data for textures. So now we're going to do our type texture data struct. And this is when we go to construct the texture, when we read the pixels and figure out the formatting and all that stuff, it's going to be kind of just all bloated into here. So mem byte, this is the data for it. Internal format is a texture input type, which we'll need to make. Format is going to be texture color format. Type is going to be texture mem type. Okay, let's make sure we type this. Texture color format filter mem type file. So let's go up here and let's add a type texture input type int. And that one is going to be const. And this is where we're going to put on all the ASTC stuff. I'm just going to type it out. Okay, so we have all the ASTCs, and then we have RGB8, and luminance. So that'll cover our type there. Then we need a width, that's right. Then we need a height, and then input type. It's going to be texture file format. And now we can create our texture. This texture is going to have a key. This is, like it would be a file path, or it would be the hash code or GUID that is associated to the particular file. This is just so that we can associate instances of textures together. Texture pixel cache. This is for when we need to write the cache out to save it temporarily. for example, on Android, whenever you background the app, you're going to have, if you have generated textures and you can't reload textures, you're going to want to cache those generated textures somewhere in a file or whatever that you can reload later. So this is just helpful. Render ID, and this is going to be whichever render ID we make. So for example, we have, where's our shader one? Shader ID. Okay, so this is inside of renderer.go. So we're going to add in our type texture, what was I calling it? Texture ID. Okay, texture ID. Okay, so channels is an int, filter is an int, MIP levels is an int, one shot. This is, actually, I'm not going to do one shot this time around. I'll see if I can do that better. I won't even bother explaining why I was using that previously in my old engine. Invalid, this tells us if it has a valid cache. Is cube, this tells us if it's a cube map, which we can probably add to our part of maybe our file format or something like that, and we could probably remove that pending data texture data. So let's get rid of that and just assume that we'll add that in possibly later. So we're going to start off by reading our blob of data that comes in. So func read raw texture data, and this is just going to take in the raw bytes for the texture and input type texture file format so that we know what type we're reading here. And this is just going to return a texture data. Texture data and res.input type is going to be equal to the input type. And then if the input type is equal to texture file format ASTC. Otherwise, if it's a PNG, we're going to do something different. Else, where it's going to be raw. So I guess we can make this a switch so it can complain to us when we compile, but we can have some compiler warnings on missing types. PNG and raw, if we ever add them later. And then, okay. So I think we'll start with the easiest one. And it's just going to be our raw format. We're going to say res.mem. It's equal to mem. And then we're going to say res.width is equal to 0. Res.height is equal to 0. We'll have to assign those some other way. Res.internal format is going to be RGBA8. Res.format is going to be equal to texture color format RGBA sRGB res dot. Oh wait a second. I just internal format. No. This is going to be RGBA unorm. Type is going to be equal to texture mem type unsigned byte. So that's the easiest one out of the way. Also, let's return the res result of this. And now for the tedious one, but the second easiest, is going to be ASTC. If mem4 is equal to 4, then this, else if mem4 is equal to 5, else if mem4 is 6, else if it's 8, that's correct, else if it's 10, else if it's 12. Okay, so I'm going to put a comment up here about ASTC. I'm just copying this from my old Go engine, or my old C engine actually. So be our our notes about ASTC and the information I got it. This is the page I got it from. Just copied it out. That's why this is in C code. It was from my C engine. So that'll be there for reference for anyone who wants to know, or reference to me later about these magic numbers, which we could make named, but I think it'll be pretty evident once we write this out. So res internal format is equal to ASTC 4x4. If mem5 is equal to 4, else if it's 5, we're going to say res internal format is going to be 5x4. That's correct. This should be 5x5. Okay. And then here we're going to have if it's equal to 5, it's going to be 6x5. If it's 6, it's 6x6. That's correct. So we're going to have 3 instead of 8. It's going to be if the magic number is 5, then it's going to be 8x5. Else if it's 6, 8x6. Else if it's 8, 8x8. Okay, there should be 4 in this one and then 2 in the next. So if it's 5, we're going to do 10x5, 6, 10x6, 8, 10x8. And then finally, if it's 10, do that. And then only 2 here. So if mem5 is 10, what do you want to do anymore? Res.internal format is equal to 12x10. Else if it's 12, is a 12x12. Okay, so that's the first part of the tedium out of the way. Now we're going to say res.width. It's going to be equal to int mem9. Res.width is going to be shift equals 8. Res.width is going to be plus equals int mem8. Res.width is going to shift 8 again. Then it's going to be 7, and then 12, and then height is going to be similar. Yep, that's right, and that's right. So resmem is going to be equal to technically the whole thing. So there we have that. Now, and the reason it puts 16 in there is because the first 16 bytes is the magic, and then 1, 2, 3, and then I guess these. It's all these headers, 3, 6, 9, 10, 11, 12, 13, 14, 15, 16. Yeah, it's this basically this block that it was trying to skip past, which I think I should actually skip past. I don't want the whole mem in there. So starting at 16 onwards, so it was right. So now for the PNG stuff, so R is equal to new bytes dot new reader. We're going to do a reader for the mem because we're going to use the internal PNG decode that is built part of Go here. So if error equal to nil, I guess I could say if error is equal to nil, then we are going to do switch img dot type. If the case is image RGBA, we're going to say res.mem is equal to image RGBA pics. And then the default case is going to be b is equal to image.bounds. Destination is equal to image.new RGBA. Image.rect 00b.dx. b.dy. Draw.draw. Destination bound source, and then res.mem is equal to destination.pics. Okay. So we may have to do something with the image color model later when it's not RGBA, and this doesn't fit. Even though this is what this is trying to do is, if it's not an if it's an RGBA, we're just going to grab the pixels. If it's not, we're going to attempt to convert it into a RGBA image and then pull the pixels from that. And that's basically what's going on here. So res.width is equal to image.bounds dx. Height is dy. res.internal format is going to be RGB8. Res.format is going to be unorm. Res.type is going to be unsigned byte. And these three, are these even set up here? I think, oh yeah, the internal format's set here. The type is not, so res.our format is equal to that, and then should be unsigned byte, most likely. We'll have to find out when we get to ASTCs, but cool. So that's all of our construction once we get the raw data and how we convert it into that initial structure that we set up for passing around that data. So now we're going to have a helper function for creating that data. T-texture, create data, image buff, bytes, override width, override height, key string, texture data. So we're going to say input type is equal to texture file format raw. We're just going to assume it's raw to start. If the strings dot has suffix, so this is a temp setting for what we're going to do here, because the key is probably going to be some kind of hash code. So to do use the asset content system to pull the type from the key. But for now, we're just going to assume the key is a string that's directing to the file. So we're going to read the raw data. The width is going to be equal to data.width. The height is going to be data height. If the data.width is equal to 0, then we're going to use the override width. Same thing with the height. And this is just going to help us with when we pass in raw bytes, we can say what the width and height are. That's what we talked about a little earlier. Now we say t.renderID, and we need to say what this render ID is because it's not set. Where should that be set? Somewhere else, just a second. I think the render ID can pull from the texture possibly. So let's just say data.width is equal to width and height is equal to height. Whereas, I mean, I could have just set it in here. Yeah, just like that. There we go. Return data. Simple enough. So we're going to create another helper function. T-texture, create image buff bytes. Data is equal to t.create data, image buff 00t key, and t.pending is equal to that data. We're just going to use that pending data. Essentially, we don't want to go in, say, the moment a texture is requested inside of the code. Let's say in the gameplay, we spawn something and it wants to create a texture. We don't create a texture immediately the moment we ask to create that object because we may be on a separate thread and OpenGL may not like it, and Vulkan, you're going to have to do all that, some extra work for. So what we're going to do is we're going to queue it up and say, I want to make this texture. Make it when it is time to make it. And then we can go through and make it when it's good and ready, the same way we did with the shader data. And that allows us to create textures willy-nilly whenever I want and not worry about what thread it's on or what rendering system I'm using or anything like that. So I'm going to do func new texture renderer. This is, we'll come back to that one. Let's do texture path string filter, and we can call this texture key. This is going to return a texture error. So not logger. Text is equal to a new texture. We're going to say the key is equal to texture path, and the filter is equal to the filter. We're going to return text at the end. text is equal to text is assigned up here. Return text and error at the end. So now we can say var image buff byte if well, here we want to check if the asset exists. To do ensure that the texture key is valid. Is valid content. Okay, and then we're going to say image buff is equal to file system dot read. This is not going to be a text file. I'm going to have a, see, this just takes and returns a string. We're going to have a read file path byte turn byte text. It's not going to be a string builder. Let's just get rid of all that. Data error copy. Okay. File. No, we don't want that. We probably want to read the file size and then pre-size this, but we can turn this into a data writer, IO writer, no, a bytes dot new, what is it? Is it buff dot? No. Okay, we're just gonna read it all. So we're gonna say buff is equal to io.read all file return buff error. Thank you. So file system read file texture key. That's what we're going to put in there. Okay, if error is not nil, we're going to return nil and error. Else, if the length of image buff is equal to 0, then we're going to return nil and, oops, I'm going to change this to if error not equal nil. I'm going to get rid of these named dudes here. Errors.new, no data in texture. Else, return, or else we're going to say text.create image buff and return text and nil. Sweet. Simple enough. We're going to have a similar delete create function, func t texture delayed create renderer dot create texture t dot pending data, and t dot pending data is equal to nil. All right, I had a random phone call, so I got to remember where I was. Looks like I am now going to be able to create a new texture from memory. So func texture new texture from memory. Key string. This is just giving it some arbitrary key so that it has one. Data byte filter int, and it returns a texture and an error. So this is basically an anonymous texture. So we'll say texture is equal to text key filter. Now the key, yeah, we may have to do some special stuff with the key that we don't want it to overlap with a real ID. So it'd probably use something other than a GUID, some kind of incrementable name or something like that. And then we're going to create the data and then text. Cool. And we're going to have a couple of helper functions. Texture read pixel, renderer, x, y, int, and then matrix.color, and then return renderer dot texture read pixel txy. So this can be a pointer. Func. Similarly, we're going to have write pixel. Or rather than write pixel, we can have write pixels. We may extend this to do a block, but for now we'll leave it as it is. So this will be a pixels byte, and then that means we're going to need a width and a height as well. Width, height, and then we can pass in width, height, pixels. Then we have function t texture size matrix.vec2 return matrix.vec2 width and height, and then that's not what we're doing. Func texture pixels from file texture data. This may be from content instead of from file. So I'm going to change this to content, and we'll just pass in the key string. And of course, we're going to have to pass in our content manager for grabbing it. So check if the content given the key exists. And we're essentially going to do what we did up here. Read raw texture data. No. File system. Oh, there it is. Just grab this guy. Okay. So if there is an error, we're going to return blank texture data. Else, if the length of image buff is 0, we'll return blank texture data. Otherwise, we're going to say t. Or let's see what we have. Read raw texture data. No, I think that's right. So that's just a helper function. Renderer. Why was that red? Mixed in name and unnamed parameters. Render. Oh, there's a comma there. Okay. Texture width, or T width. We don't have texture width and height. We can store it in here though. Wouldn't hurt. There we go. We don't have these functions yet. Texture key, this is just key. I guess we can keep that, it's the same name there. And then create texture. We don't have that function either. So these are the three functions we need to write. Create texture, texture read pixel, texture write pixel. So those are going to be a part of this guy. So we have ready frame, create shader, free shader, create mesh. Probably going to need a free mesh at some point. To do implement freeing of meshes. We have create texture. We don't need an asset database. Create texture t pending data is going to be texture data pointer. Texture data. Okay, then we need the texture read pixel. And texture write pixel. So you'll read and write differently depending on the renderer. Okay, so that makes our texture stuff done and happy. We now need to implement our texture cache. So package, rendering, type, texture, cache, struct, renderer, textures, give me a map of string texture, and then pending textures, texture. This is going to be similar to the shader cache. Asset database. I guess we are going to use the asset database. Didn't remember that I stubbed in that. Which means we could probably use that in the other place because the asset database is going to need to have, let's see, read. It's going to be read text asset. Oh, it doesn't like it because of errors. Read text asset. Okay. Asset database, read text asset. Read asset. Read file. This will return a byte slice. Then we're going to need a func a database asset exists key string bool. No, we don't need refile. Copy file. Func exists path string bool. This is pretty easy. You just got to stat it. So stat os.stat path return error is equal to nil, and stat is not equal to nil. Should make a file exists and then say stat.isdir, so it's not a directory. And then we can make a directory exist. Directory exists is a directory. Okay. Now let's unwind some of this stuff that we were doing. Return file system file exists key. Cool. What was I doing here? Read text asset. Okay. All right. So back to what we're doing here. So func new texture cache. This is going to be similar to the shader one. So let's see, texture and pending textures. Okay, and then we're going to have not a create texture, but just a texture, which will create a texture if it needs to. And this is going to be similar. I want to make sure I'm similar to this here. So this is going to be texture key string. So it's going to change all of what it generated there. So let's look for the texture. If it's there, we return it. Else the texture is equal to new texture. Is that not what we called our function down here? New texture. Yeah, okay. It's just bad arguments. So the renderer is going to be t.renderer. The texture key string, texture key, and then the filter is what we need to pass in. So the filter, we can use texture filter. I don't know why I'm passing ints around here. New texture filter. Okay. Texture filter. This one, oh wait, we need to pass this in. Filter, texture filter. Now, of course, this texture may have a different filter, so that's something to think about at some point. Nothing I'm too worried about at the moment. If texture, or if error is not equal to nil, or error is equal to nil. Otherwise, this should return an error as well. Okay. So now we need the create pending function. It's just going to go through the pending textures and call delete create with the renderer attached to them. Now we can pass the asset database in here now. We have the renderer asset db assets.database, and we can now say if asset db lowercase b, why not, dot asset exists texture key. Then we are going to do this stuff, else return texture does not exist. Texture. Since I already named it asset, I should probably change these to asset. So if, oh, this needs to pass in the asset database. db assets.database. If asset database exists, do this stuff, else return blank texture data. I guess this could return a texture data and an error. Keep things consistent here. Okay. So that means here we're going to need to pass in a t.asset database for our texture caches. Okay. So that's it for our texture cache and for our texture. So now we need to implement our functions, like create texture here. Not inside of the texture cache, inside of renderer.gl. Mesh. Okay, let's make it down here. RGL renderer create texture. So we're going to say texture.renderID is going to be equal to GL create texture. I think I call it gen textures 1, and we pass in this render ID. So we're actually going to say ID is equal to 0, pass in ID. And this should be a texture, right? GL handle. I'm probably going to change that to texture later. So var ID gl.handle, and then that's going to be equal to ID. That's how we're going to set that up. So gl.bind texture. We're going to bind gl.texture2d, texture.render. All right, we'll just pass an ID there. gl.text parameter I. We're going to do, actually we're going to do texture wrap s, repeat. Then we're going to do linear map linear, and we're going to do linear there if texture dot pending data dot input type is equal to texture file format ASTC. We're going to do gl dot compressed text image 2D. And let's see what it generated here. Texture 2D 0. This internal format we need to convert this to a GL internal format. So I'm just going to say 2GL internal format for that. Then we're going to say texture pinning width, height 0. And then this is just going to be .mem ASTC header size, which is going to be that 16. Actually, we don't need to do that because we don't apply that memory. Although it'd be nice to keep that memory. Got to think about that. Then all the rest of this is probably going to be the same with height 0 mem. Yeah. Okay. Come back to that thought for now. Internal format, so we're going to copy this. And then width is going to be, these need to be int32, int32. Format, 2GL format. Gonna need that function. Pending data, GL handle. We'll say 2GL type. And then mem here. This is an unsafe pointer, so mem 0. Okay. Okay, and then same thing here. Okay, a few things we need to create. So first things first, we're going to go to GL. I forgot what I called it. Oh, it's not in GLES non.js. And then the new ones, repeat, linear, linear. Okay. Next, we want this compressed. So let's go to this function, and we're going to add in the func compressed there. Okay, and now we'll come back to making those in a second. Let's finish up this gl.generate mip map, gl texture 2d, gl.unbind texture 2d. So let's add this function, generate mip map. Func generate mip map. So I'm just going to create a GL renderer helpers.gl.go rendering. And of course, this is going to have the same. Oh, I don't even have it here. I should have build flags there. I think it's OpenGL all uppercase. OpenGL. Go build OpenGL. Okay. Go build OpenGL. Okay. Just going to create those helpers real quick. Gotta go find them. Okay, found my helper functions. I've got a pad ben. This just pads to 16-byte alignment. Here's our 2GL draw mode, which we haven't used yet, but we will. This just takes these guys, which don't exist. I guess I should make them mesh.go, just to stub them in here, const, and then let's take mesh draw mode type, and then let's just paste those in. Okay. So triangles, patches, those fall through to default. Next, we have 2GL internal format, which just takes our version and converts them to the GL one. Oh, these need to be fixed real quick. I use this snake case, screaming snake case before. So I'm going to make those standardized. I'll go back and do that. Then we have the texture color format stuff, and then we have our memory type stuff. So let me fix this screaming snake case. Okay, I went through and fixed all those guys up. Cool. We'll get any of the rest of the errors when we finally compile. So let's go to the create texture. Okay, we need our other two functions, which is going to be the read pixel, read pixel and write pixel. Okay, I've just came in and we're going to do the pixels later for the write, and then this one we have for the read pixels. We're just, what is this for? No, we need texture width. There we go. I added the bytes in pixel to 4 because everything's going to be RGBA with what we're doing. And then we're going to make use of the texture cache. If we have not created the cache yet, we are going to then set it up so we can get the texture. We can set up the cache. We can then read to the cache if the cache is invalid, which we're not going to set here yet. I'm going to have to probably come back and optimize this, but we're going to have this GL get text image function, which I didn't make. So let me add that to this guy, func get text image CGL. Okay. And then we're essentially returning that pixel. So this is going to be optimized a little bit later, but I think I need this for something I'm going to be messing with in a personal project, so I'm dropping it in here for now. So just because we went down so many rabbit holes, I'm going to build and figure out where I left off by seeing what the errors are. Okay, so we start off with not enough arguments to call GL compressed image 2D. Okay, so what are our, it's not wanting to go. This is one of the things I have a problem with our build flags like that. I'm going to go and let me see. Did I set that up inside of the VS Code? Settings, go dot build tags OpenGL. Will that make you happy? No. Oh, it's gonna load. Let's see if it figures it out. Okay, cool. some stuff has been figured out. So we need, let's see, the handle, or the target, the level, internal format, the width, height, border, image size. So this is probably going to be the length of our data here. And then the unsafe pointer. So this needs to be an int32. These are also going to want to be int32s. Format. This one's complaining about, can I use this function? Value type of uint32. This should be gl.handle. I'm pretty sure. Handle. Okay, wants to import GL. And of course, points, lines, angles. So we need to add points and lines. Points. That one. RGB A8. RGB 8. Okay. RGB. No, RGB. And then unsigned byte. Let's see, where's the unsigned int? Unsigned byte. Okay. Cannot define new methods on non-local type. Mesh draw mode. Oh. We set it to an equate mesh. So we'd have to remove that equate. Okay. Now down to this guy. A texture color format. Internal format. Pending data dot format. Okay. Should be matrix dot color. Texture dot cache. Texture pixel cache. Oh, this wants an unsafe pointer to it, so put a 0 there. Matrix WebGL GL renderer. GL renderer. Okay. So let's see if that cleaned up most of that. Okay, we got another error here. Window.go. Renderer, new GL renderer. Does not implement, it's not implementing one of our renderer stuff. So let's make sure this is set correctly. This, I'm just going to copy it, paste it, make sure these are all set correctly. Oh, pixel. This should be pixels. Okay. Texture right pixel, right pixels. Okay. All right. Now we're back to where we were. And we have the texture code in place. So now we go about the funny business of trying to get a texture actually showing. So let's open up basic.frag and let's add in a uniform sampler 2D text sampler. And we're going to use, I think it's texture text sampler. We're going to need to have the UV coordinates, and then we're going to multiply by the frag color. So we're going to need to have a input of a vec2. I'm actually going to call this frag text chords. And that's what we'll pass in there. So now let's go to basic.vert. And we're going to out vec2 frag text chords. Frag text chords is going to be equal to UV0. Now we're just going to hack in a texture onto one of these guys, just to, or onto both of them, I guess. I just want to make sure this stuff is working. So let's go back to main. Let's go into our draw, implementation of draw, please. And then we're here where we're binding the instance sampler, we can set up to bind our other data as well. So we have that texture set up. So let's try doing we're going to do gl.activate texture, gl texture 1 in this case. And then we're going to do gl.bind texture. And then we're going to have, I don't know, we're going to have some arbitrary texture that we can work with here. And then we're just going to pass the ID gl.uniform1i. And then we're going to say the texture location, which is basic frag text sampler, and we're going to put a 1 in there. So this will be our test. So let's go create a texture 1, which could be just texture 0 plus 1, no difference. And here's where we're going to get the texture ID. So we can make it a part of the stuff we're drawing. When we do an instance group, we are going to use the same texture for that instance. So I'm just going to put it in there for now. Oh, texture data, draw instance group. Oh, this is the texture data for the instance. So now we have, we can have textures, an array of textures. And that way this would become like a for loop for I, texture, range textures. And this could be texture 0 or texture 1 plus I for this. gl.handle, gl.int, or glint, int this and that. Okay, and then this will be texture.render ID as GL handle. And this will be I plus 1. And that's going to be the N32. Okay, so that'll go through and bind the textures. And of course, this uniform location is going to have to actually be something else to do get the uniform location inside of our set get the uniform location as part of draw textures. So we're probably not going to have raw texture pointers in there. We'll have a struct with the texture and the sampler name in there. But for now, we've we've got this set up. I'm going to move this up here. Okay. So we don't have our unbind texture, which is going to be after we unbind the buffer. So gl.unbind texture, texture 2D. Okay, so now all we have to do is add in our texture to one of these guys, which means I'm going to need a texture. Okay, I just grabbed this Android logo PNG here, which we are going to use. It's just something I had on hand, nothing special about the Android logo there. So here where we create our second triangle that's moving, I guess we can do it to one that's not moving. This T here, T dot, oh no, not the T. When we add an instance to rendering instance T triangle shader data is a rendering instance. We're adding it to our draw group. We could just say, oh wait, no, this is instance, so both of them are going to wind up having it. Textures is equal to rendering texture. Oh yeah, we have to add the host cache in there. I'm actually going to rename this to Android. Cool. Android. Texture cache, p host.go. Let's see where we have our shader cache. Let's add in our texture cache. So we're going to say host texture cache, create texture, or it's just texture. Then we have the key, which is going to be file path, and then we're going to do nearest, texture filter nearest. And this returns an error, so droid text. I'm just going to ignore the error. There shouldn't be an error. Probably. So let's see where we get to at this point. Okay, do we have a droid texture? Content Android, it has no width or height. That's not a good sign. Oh yeah, we have pending data here. So this is a good sign. So now we actually need to create the pending instead of the cache. So let's go to the host, pending cache, create pending. So host.texture cache, create pending. Okay. And let's just let it rip and see what happens. If our triangle disappears, we know why. Oh, of course. Render create texture, the pending data. Was our panic? Nope, come back. I'd like to remember what the panic was, please. Invalid memory address or no pointer dereference. Renderer. Oh, we don't have a renderer coming in. Oh, we didn't actually create. Let's get our hosting, create our texture cache. Shader cache, host.texture cache is equal to rendering new texture cache and take in the assets, the asset database. Okay, so, progress. That means the texture failed to load or something like that. Actually, I'm going to run this and then run renderdoc. Okay, we're in renderdoc. We can come over. Here's our texture. It's upside down. Oh, we probably don't have UV coordinates on the. Where did we add UV coordinates? We have a position and a color. We don't have UV coordinates, so we need to add in UV coordinates. So UV 0. It should be right. So let's see where we're at with that now. See if it gives us anything different. Hey, there's our androids. And they're colored correctly. They are upside down because we need to deal with GL's image flipping stuff. Actually, now that I'm thinking about it, related to this flipping stuff, let's go and see where's our renderer initialization. Here's where we set up our new GL renderer. So it's inside of our window, right? So this Win32 stuff, set up OpenGL context. Let's see. Yeah, so that's fine. We're going to come over here. The renderer should be made after we've created our window. So what we're going to do is say R, turn R, and we are going to do gl.enable, gl.call face, gl.enable, gl depth test. I'm just going to add in a bunch of this stuff. gl.depth mask is going to be true. GL depth function is going to be, we're going to do less than equal gl.disable, gl.stencil test. Might come back to that. This is just some default things that we're going to do. gl.enable, gl.blend, gl.blend func. It's going to be source alpha 1 minus source alpha, front face, gl.ccw, gl.get extension. This is going to be for the WebGL stuff. I might actually just copy these sections here. I'll just comment these out. To do for when doing WebGL stuff. Okay, so we need to make these guys. GL. Actually, let's make the constants first. Call face, depth test, L equal, stencil test, blend, source alpha, 1 minus source alpha, CCW. Now we need the enable function. Of course, if I was smart, I would generate a bunch of the stuff, but like I said, we're not doing the entirety of OpenGL right now. We're just doing the stuff we want, and it's nice to see exactly what we have available. Kind of makes it so that there's a reason for adding new ones. A reason for adding new stuff will have to be argued, kind of thing. Disable. Let's put this up here. Blend func. And front face. Okay, so we need to make this guy. Cool. All right, so let me just make sure I didn't break anything. Then we'll go back to what we were doing. I did break something. Probably when we are calling GL renderer. New, let's see. Oh, we are creating it before we are creating the window. So I don't think we need it before we create the window. So let's just take this and faithful HWD address. let's do it right down here towards the bottom. w.renderer equals. Okay, let's see if that makes it happy. Oh, I've made it mad. It might have to do with my face winding. Oops. Okay, it was not my winding. It was my depth testing was tripping it up. So it might be how I'm dealing with possibly not clearing the depth test. Let me see. The gl.clear screen. This calls clear screen. What does this do? Oh, this just kind of stuck in there, huh? This is a good time to change this. Do I have a GL clear color already? Nope. Do I have a GL clear? Nope. Okay. Good thing. Let's just put this in here. And this would be CGL. Void CGL. Clear screen. Okay, get rid of this guy. Actually, I'm going to cut this. Get rid of that. Clear screen. I'm going to put these temporarily. GL clear. Func clear. And then func clear color. CGL, CGL. Okay, let's cut this stuff. Now, where were we calling that clear screen here? Let's just GL dot. Let's get rid of these Fs. Okay, and we're going to do GL dot color buffer bit. And we're going to do depth buffer bit. Let's add these bits in. Cool. So that should make it happy. Oh, did I even bring back my let's see. It's working, but let me make sure. No, I didn't. Try that again. Okay, cool. So that's happy. Now we just need to deal with the flipped image. Okay, for now we're just gonna deal with flipping the image ourselves. So we're gonna do var mem uint8, I think it is. So mem, we're just gonna grab that data. So for length and mem plus equals 4 because we did make it RGBA, so that's right. We want to do essentially, I guess I need to figure out, hold on, I'm just going to do this real quick. We need to figure out, it's just upside down as far as I know. It's not upside down and flipped backwards. So we just need to take the stuff on the bottom and put it on the top. Of course, this Android is symmetrical, so we'll probably have to just go off of our gut here. So we want to go through the height of the image. So we'll do res height. We're going to go through the height of the image. We'll set this to y++. Y is that. y is less than the height. So I'm going to start off at the top, and then we're going to work our way down it. So I want to do a copy to mem is a byte. So let's just make this a byte so the generic works out. So we want to copy into the destination res.mem. Let's make a from and to. From is equal to y times width times bytes and pixel. To is equal to res height minus y minus 1 times width times bytes and pixel. So here we want to basically convert we're going to we're going to say slice dot grow. No, we can just create it. Mem is equal to a new byte array of not 0 but length of mem. That way we can say we're going to copy to res.mem, and we want the slice of 2, so it's going to be to this and then 2 with I'm just going to make that byte width. Let's take this, put it there. 2 plus the byte width, and then we are going to copy from the source from plus byte width. So I think that should flip us. Let's see what we broke. Okay, cool. So those are our android legs, and his head has disappeared because it's a triangle. Awesome. So I think with that, yeah, he's symmetrical. I think with that, we should be pretty good. We have our texture flipping done as part of our PNGs. I don't know if we need to flip the ASTCs, and we definitely don't need to flip raw. So something to just keep in mind. Cool, so now we have our textures. It's rendering with part of our draw group. I think there was one last to do inside of our renderer GL textures. Yeah, the sampler stuff. So we are going to leave this for another time, but I think this is long enough as it stands. We have textures now running and working for us to play with.